So, in the last episodes, you learned how we use the chain rule to find the derivative of a function by dividing it into two functions. And now, in this episode, you will learn how to find the derivative of a function with the help of chain rule by breaking it down into three functions. And as per the chain rule, if y is a function and if y can be shown to be composed of three functions y, u and v, then in that case the derivative of y with respect to x is equal to the derivative of y with respect to u into the derivative of u with respect to v into the derivative of v with respect to x, or in other words, dy upon dx is equal to dy upon du into du upon dv into dv upon dx. And now let's make use of this chain rule to solve one more question. So let's solve one more question, and the question is, find the derivative of secant of log of x raised to the power n with respect to x. And just like we have been doing in other questions, first of all, in our first step, let y be equal to secant of log of x raised to power n. And now let's first of all break it down into three functions. And our first function is y equal to secant of log of x raised to the power n. And let the second function v be equal to x raised to the power n. And let the third function u be equal to log of x raised to the power n. But x raised to the power n is equal to v. So in other words, we can also write u as u equal to log of v. So now we have got three functions. In the first function, y is equal to secant of log of x raised to power n, and in the second function v is equal to x raised to the power n, and in the third function u is equal to log of v. And here we have to find the derivative of y with respect to x, or dy upon dx. And as per the chain rule, dy upon dx is equal to dy upon du into du upon dv into dv upon dx. Also in the first function, y is equal to secant of log of x raised to power n, but log of x raised to the power n is equal to u. So we can also write y as y equal to secant of u. So now y is equal to secant of u, and u is equal to log of v, and v is equal to x raised to the power n. So let's first find the derivative of y with respect to u. As y is equal to secant of u, then in that case you already know that dy upon du is equal to secant of u into tangent of u. And for the second function, u is equal to log of v. And what's the derivative of a logarithmic function? You already know that the derivative of log of x is equal to 1 upon x. So here du upon dv is equal to 1 upon v. And in the third function, v is equal to x raised to the power n. So that means dv upon dx is equal to n into x raised to the power n minus 1. And now in order to find the dy upon dx, we shall have to multiply all these three derivatives. And after multiplying these, dy upon dx becomes secant of u into tangent of u into 1 upon v into n into x raised to the power n minus 1. But u is equal to log of x raised to the power n, and v is equal to x raised to the power n. So substituting the value of u and v into this equation, then dy upon dx becomes secant of log of x raised to the power n into tangent of log of x raised to the power n into 1 upon x raised to the power n into x raised to the power n minus 1. And now cancelling x raised to n minus 1 from the numerator and denominator. So finally, dy upon dx is equal to n upon x into secant of log of x raised to the power n into tangent of log of x raised to the power n. So that means the derivative of secant of log of x raised to the power n is equal to n upon x into secant of log x raised to the power n into tangent of log of x raised to the power n. So how we solve this question? So in order to find the derivative of secant of log of x raised to the power n, first of all we broke it down into three functions, y, v and u. Then we found out the derivative of y with respect to u, and derivative of u with respect to v, and derivative of v with respect to x. And finally, after using the chain rule, we multiply all these derivatives, and finally we got dy upon dx.